Thanks. I'm doing a talk showing the other side of the possible stream implementations based on reactive streams. In addition, I'm showing some project I started, and this is now a Karaf sub-project, which is named Reactive Components, which kind of complements reactive streams on OSGi in a nice way. So, first a bit about me. My name is Schneider. I'm married and have two lovely daughters, as you may be able to see on that not so good projector. I've been working for the last 6 years as an open source architect at Talent, so mainly on Apache projects like Karaf, CXF, Camel, all the integration space. And since October now, I've started a new journey at Adobe as a computer scientist on the Experience Manager platform team, which is luckily also based a lot on Apache projects like Felix, Sling, Oak. So it's a bit different scope, but still mainly in the OSGi space. So interesting new possibilities for me. There, I have a Twitter account, so I will later publish the materials about the talks I did on Twitter, of course also on the conference channels. And I've got a website where you can also find some tutorials about OSGi and Karaf, which might be helpful. So let's look into reactive from the way the reactive manifesto defines it as responsive, elastic, resilient, and message-driven. So basically, the responsive part is where you get your value from. Responsive means that if at all possible, the application should respond in a short time in a reliable way. And elastic means that you can react to new demand, you can fan out, you can scale to what is needed. Resilient means that you can cope with failure. So basically the idea is to isolate failure ideally in a small module and not let it basically take your whole system down or your whole cluster. And message-driven is basically a means to achieve that, which means you're fully asynchronous, and this can be inside the application, like the streams work. It can also be over boundaries, like with a messaging system. So let's look at the spec. Oh, that's not so ideal. I hope you can halfway read it. I will tell it. There's the publisher in reactive streams. There's the subscription and the subscriber. So basically it works like that. The publisher creates a subscription and the subscriber later uses it. And there's also the processor, which just is a publisher and a subscriber, and could be something that is in between some pipeline. What is very interesting about reactive streams is that even if it's quite fresh, it's already supported by a lot of projects. So there is, of course, RxJava, one of the kind of founding projects of it. There's Project Reactor, which is very similar to RxJava. It's basically more or less the same people who just said, let's base that on pure Java 8 and be able to cut down all that is not possible on Java 8. So it's Reactor is a bit a cleaner implementation of the same thing. This is a bit more modern. There is also Jetty, who has a module for reactive streams. OrientDB, Akka is one of other implementations. Vertex supports it, MongoDB, and it's also part of Java 9, at least from the API part. So I think even if it's really true, like Tim explained, that push streams have a lot of advantages and the different way of looking at streams, I guess the market will say that Reactive Streams is probably the dominant platform in the future. And so what I'm looking into is how to use it just instead of doing it differently. There's also the back pressure part. Oh, this is not correct. So we have the publisher, a subscriber. Subscriber subscribes to the publisher. On subscribes, it gets a subscription. It's here. And then on the subscription, you can request events, and then you will get them in an asynchronous channel on next. It's also typed, as you see, and in the end, it can be on complete or it can end with a failure. So this is a pull-based approach. Also, like Tim described already, it works very well if your protocol is pull-based. That's true for example, JMS, Kafka, or you take messages from IMAP. It's not so good for something that just pushes stuff to you, like HTTP or Event Admin or MQTT. For what I later implemented, I sometimes just ignored these specification demands of not sending things if they're not requested. It still practically works, but it's against the spec. But let's see. So a very interesting part of that is Project Reactor. It's the kind of successor to RxJava. And the most important thing about this is that it's the foundation of Spring 5. So you may say it's good or bad, but as the core part of Spring 5, it is just probably all over the place, because with Spring and Spring Boot being based on it, people will use it all over the world. So I think it will spread a lot in usage. The interesting part is, and I actually did not expect that from the Spring guys, which are also behind Project Reactor, but it's a separate entity. It doesn't have any dependencies, which is very unusual for Spring stuff. So basically the only dependency it has is the Reactive Streams API, which is of course needed, and it's out of the box OSGi ready. So Reactive Streams is a bundle, and Project Reactor is a bundle, so you can just install these into OSGi and it just works. This is an example how Reactor DSL looks like. This is a Flux which creates an event every millisecond. This is implementing a moving window where you say, take the 2 last events and give me a sub-flux of these, and then move 1 event further. So you always get the 2 last. If you would say window 2, colon 2, it would always jump 2 events. What I do with that in this example is just use flatmap to go over that window and create a double over the 2 elements and return that as a new event. So in the end, I have these averages over the last 2 items, print them out, and this is what it looks like. Because what comes out here is starting with 0 and then counting upwards. Just going to sleep. So this is something I started first as a private project, and now it's a sub-project of Apache Graph. It's very early still, but I hope it's something I can kind of spread the word about and make a bit more well-known. Who of you knows Apache Camel? So quite a few people. And I think Camel is a really great idea of how to integrate different protocols and do some processing in between, but it's kind of gotten a bit old. I will talk a bit more about that later. But this is the same idea as Apache Camel, but reduced to the core of it, like the components. And a reactive component is just this interface. You have a method from, which means this is something that attaches maybe to some external protocol. and gets events in and puts them into your DSL pipeline. You can say which destination to listen on, and you can also specify what kind of type you expect from the events. So there should be some conversion between what comes in and the type you expect to come out of it. Then there is to, which is the other side. So in the end of such a Flux DSL, for example, with a reactor, you could say, I want to send to some external protocol, and can also say what is my type that is coming into that external thing. And this is something I had to extend. Originally, I used just publisher and subscriber, but as Tim also described, you need some way to stop such a stream once it's started, and there is no way to simply do that with a spec. So what I just did is a closable subscribers and interface that extends or implements a subscriber and also is closable. And when you close it, it's closing the subscription. So basically, it's doing what you need to shut down streams. As an example, the MQTT Reactive Component, it's very simple. It's a declarative services component that expects a configuration where you can say where's the server, username, password. This is all in part of that component. You can also make several of them with a factory configuration and say I connect one to this server, one to another server, and it produces or publishes an OSGi service with this interface we just looked at as the service interface, and name MQTT as service properties, so you can relate to it. And this is the way to use that in your declarative service component that you write yourself. You just put a reference and filter for the name, or whatever properties this component will maybe also publish, and then you can just use it. And you use it inside Reactor, but you're not, that's the interesting thing, this reactive component is not tied to any DSL. It is just this interface that is just based on the reactive stream spec. So you can use it with Reactor, you can use it with RxJava, I guess also with Akka, so it's completely independent of the DSL you use later. But it has to be reactive streams compatible. There again, every second we send an event or create an event. We convert from that long to a byte array because at the moment this MQTT component just accepts byte arrays. And so basically what that does is it sends every second to MQTT. And the nice thing is that in this example, which is your user code, you have that and that. You're not depending on MQTT itself. You're just depending on this simple interface that itself just depends on Reactive Streams API, which is really small. So you can make your user code independent of the actual protocol you're talking to. That's like in Camel. But it's a lot smaller in surface area of your user code to the platform. So, of course, you could say, why not Apache Camel? Apache Camel can do the same I just showed. It may be not easily to do that with Reactor, but Camel has its own DSL. It's working great. It's proven to work. But the big problem in Camel, and I'm also committed there, so I know a bit about the internals. And while it's really great for users, the internals are a bit old. So in the start, it was a really great little idea and had a great concept and a small implementation, and over time it grew in functionality. Like Tim described in the keynote today, when you start a project and you get more and more things that you should implement, it has grown a bit too fast and not modular enough. So Camel Core is the core of Camel, but it's not only an API, it's also the implementation of the DSL and even some components. So every Camel component needs to depend on that, and because of that, it's not possible to really change a lot in Camel. So while Camel is not bad today, I doubt it will be good in 10 or 20 years because it just cannot easily evolve without breaking everything. And it's also, there's no support for back pressure in Camel, and I guess adding that to Camel would be one of those breaking things that would make it tip over. The good thing is, as Camel has so many interesting protocols, you can actually use it together with reactive components. I've written a small component for Camel, and the nice thing is that Camel already has an adapter built in to RxJava or to reactive streams in general. So it's possible to bridge those. So you can use then Camel in reactive project Reactor Flux. And I just made this a little bit more easy by offering a reactive component with this rcomp interface that you can use with any Camel component. Instead of the destination there, you just specify the typical Camel URL for any component you want to use, and you can. So this is, of course, we just heard a lot about push streams, and I really like the concept, and I can imagine that it's really maybe better than reactive streams. But there are some problems with it that are sometimes outside the scope even of push streams. It is not only OSGi, you can use it everywhere, but at the moment it's only known in OSGi and only used in OSGi. So the ecosystem around push streams is very small at the moment. And I have I think that with Spring 5 spreading, people will use reactive components all over the place, and it will be really difficult to, not reactive components, reactive streams over the place, and it would be difficult to compete with that and try to reach a similar ecosystem. And the other thing is, it's unfortunately, of course, based on the push nature, not compatible to reactive streams. It would also be difficult to make it compatible. If not, probably doesn't make really sense. And the last thing is, or one other thing is, it does not have a real API for components. So the nice thing in reactive streams, I think, is that it's just these few classes, few interfaces, that is the core of it, and that, for example, my little framework, reactive components, can build up on, Jetty can build up on, all the other implementations can build upon without making themselves dependent on the DSL. And in push streams, it's both together. And I think one thing that could be maybe improved in push streams is to have some small core of it that is like this reactive streams minimal API.
You just have the push event consumer and the push event source.
Yes, yes. I think there just should be, they should be separately usable, just as API.
They are.
They are even already?
Interfaces, you don't need any of the rest of it.
Okay. I think the important thing would be to be able to just depend on that little thing and then build other implementations around it, maybe even other DSLs. And I think that's the nice thing in the Reactive Streams API, that it's so small that people can do very different things with it. So at the moment, you cannot use it with a different DSL. Maybe that can be even changed. So I have a very small demo, actually. Well, first I guess I should show a bit the code. This is the API of reactive components. As I've already shown, this is the central part of it. I've added some small things like require component. This is using BND annotations. So basically, as reactive components are so decoupled to the implementation, like you just depend on a service, So the OSGi resolver will have difficulties to provide you automatically, for example, if you use the MQTT component with its implementation. And if you add that to your user code, you can say which component you want to depend on, and then the resolver can do it for you. This will be with OSGi R7 be able to be done with standard annotations. And this is just these closable subscribers, so it's just subscriber and closable, not much behind it. Then let's look into a very simple component. That is actually not really according to the spec, like I already knew, but a bit ignored for simplicity. Yeah, let's start from the inner thing. This is the component where you depend on the config. You can configure all that is necessary for an MQTT connection. It is published, and the client connects when it activates. And then you have this from and to, and can basically create your integrations with reactive streams. And if we look at MQTT source, this is exactly where it's not compliant. It makes its life easy. Just when you request the first time, it subscribes, and then it just goes on next. So the current implementation does not do this checking that you're not delivering more than is requested, but it still works. It's not compliant to the spec, but it already works with Reactor. And it could be made compliant at any point. It's easy. You just have to improve the components to be actually following the spec in detail. So basically, what this does is implementing the spec, and this is how to use it. We just look into a small example. Like this is something that sends to MQTT. So as I described, you filter for name MQTT. You can also say this component requires MQTT. This is just a helper for the resolver to do that. And when this thing starts, it's calling to from the MQTT component and creates a flux that sends out just to this topic. And to close it, we use onComplete when it's going down. And this is something in between that's listening on MQTT and does this average, like I showed already, as a small demonstration of it, and just then sends out to another MQTT topic. So there's still this conversion done at the moment. This can even be improved. So the idea of reactive components allows that I, for example, here say integer and here say a double, and the converter inside the component could do this conversion, and with the new OSGi converter spec, we could reuse that to make that really like in Camel. So as you see, it's already very similar to Camel and works very similar. And this is the last part that then again listens on MQTT and just sends it to the log. So we could start that. One thing to show is maybe also how you can use that with B&D tools. So I've defined an app here. I have to make it a bit larger. So there is a POM file that defines all the dependencies of the reactive components and the example, and I've provided a small bundle that pulls in all bundles you need for shell and config admin, and to make that simple. And yes, now if we want to add our example, we can just move that over and do a resolve, and get a fully working list of bundles that can run this. Unfortunately, the shell is not so nice here, so I will use Graph to look into that. So bin Graph. Check the time. How much time? 10 minutes. Okay, so we can actually start fresh. So I'll show how to install that. So typical for Graph, you can just paste some shell commands and get it all installed into a plain Graph. So what this does is it configures the MQTT component to use our MQTT server on localhost, and apart from that, install the MQTT, the rcomp repository, and there are the examples. And this examples feature already pulls in component it needs. So this is all that is needed to start. We have this rcomp API, event admin. It's also part of that example. And mail MQTT. These are the components we use. And as you see from the dependencies up there, the rest is standard Graph stuff. So it's really still very small. You also see the reactive streams, so Reactor core and reactive streams. These are the only two things that are needed to run this reactor. And now we enable this emitter component. Let's just list. And now if we look, we see that it's going from the emitter to the component that processes the average to the receiver that actually sends it to the log. You can also disable the component again. So we see the shutdown also works. Actually, it should shut down. I don't know what happened now. Well, demo effect. So normally it should just shut down at that point. So basically, what I liked to show is there is this subproject of Apache Graph. It's in its very infant stages, but I hope some people help with that, and maybe will that even allow some kind of successor to Apache Camel when the point is reached where Camel cannot be adapted to the future anymore. And I think this reactive path is a better path to go than to follow the old Camel way all along. And maybe there's even a way to combine that with push streams at some point. I would hope so. But at the moment it's difficult because those APIs are very different. Yes, back to the presentation. So there are other things I found while doing that. So reactive in principle is a good idea, and I think in many situations it may be actually needed to cope with the loads that can exist in a cloud environment or IoT environment. So it's nice to make your system more resilient, and with the back pressure you can react better to overload situations. It is also easier to write code in an asynchronous way if you use such a DSL like push streams or a Reactor than to just try to do it manually, because that's almost impossible. But it is not easy. So the first blocking point is whenever you have something that is blocking, it will destroy your whole pipeline. For example, if your database does not offer any way to work non-blocking, it doesn't work. either you go full way non-blocking, or you can also not do it. So one point is you really need all components on your way to support this way of working. And maybe that's happening for reactive components because it's a large ecosystem, but who knows? And the other thing is that even your user code, if you have existing code, is typically blocking at the moment, and going the way to non-blocking to reactive is not as easy as it looks when you look at some simple examples. I tried to create some more complex examples, and I didn't get too far with it. I'm not really a specialist in these DSLs like Reactor, but it's not easy to get into that mindset. Maybe it's just something you have to accustom to, but I think it's also more complex from thinking than our normal way we code. So it might be a rocky road to that reactivity. So it's a really steep learning curve. So that's already the end. As I said, I will publish on my Twitter account, Schneider Chris, where you find this, where you find the reactive components and everything to get started with that. So many thanks, and are there any questions?
Yeah, we have some time for some questions. Any questions? Thank you very much, Christian.
Thanks.